Hello everyone, my name is Yalei and I come from Huawei. And today my presentation's name is Integrating VPP host stack and RDMA via DMM. Actually, DMM is an open source project which joined FD.io community this March. And today I will mainly introduce the latest progress of DMM project. But first of all, I will give you a brief introduction on the DMM project. Okay, first I will revisiting the DMM and I will introduce current challenges of our current protocols and protocol stacks. And then I will have introduce how DMM try to solve that problem and his solution, what is his solution. And the second half, I will introduce the current advancement of the DMM. I will introduce how we integrate two protocol stacks, VPP host stack and RDMA stack, and show a demo about an unmodified nginx, which using both RDMA socket and VPP host stack socket. So finally, I will introduce the roadmap. Okay. Currently, when we discuss about the TCP or the protocol stacks, we always talk about TCP. But TCP is not always the best choice. It is loss sensitive and hard to tune the performance. And also another problem is operating protocol stacks is provided by operating system. So it always be the kernel stack. But the kernel stack is monolithic in design and inflexible in nature. It is also hard to customize. And most of the time, it could transfer the data safely, but not always the best choice. So for these two problems, we have two trends. One is several companies provided their own transport protocol, like Google provide QUIC based on UDP, and IBM provide FASP. And also another trend is moving the kernel stack out of kernel. So we have user space I/O driver like DBDK and the VPP host stack, which provide the capability to give a better performance. So, but consider more that we have all the optimization is a trade-off between the factors. So not only one protocol will fit all the scenario, because the networking APP has different requirements, like in 5G wireless scenario, maybe some AR, VR application may need the lower jitter and latency, and some high definition video application may need high bandwidth. So application requirements is not always the same. So then why the protocol should be always the same? So we are thinking how to try to solve that problem. So as this picture states that if protocol stacks are infinity gems, so where is the infinity gauntlet? So that's why we introduce DMM. So DMM is a kind of framework that make all the protocol stacks working together, and they can run simultaneously. So in the northbound, we have the Pockets API, which hijacked from the application. So different applications, POSIX API will be hijacked by SBR layer, and the sourcebound it will wrap the different I/O base. It may be DBDK, NetMap, or something else. So, and in the right side, the green box is a local agent. So this agent will coordinate with some protocol stack controller. That controller will negotiate with this local agent and define the protocol routing. So that process we call protocol routing or RD. So DMM is provide dual mode. The D here means dual mode, means not only the user space and also it supports the kernel space. And the multi-protocols could be running together, and it provides protocol selection for them. Okay, so this page will introduce how the protocol routing work. So this is end-to-end. So the right side is the end-to-end connection process. So when the application client and server communicate with each other, some POSIX API will be hijacked, and then it will trigger publishment. Then the application's requirement and the current configured DMM available protocol stacks will be published to the policy controller. I mean the center RD protocol routing controller. And then protocol routing controller will generate a criteria table like the red box. So it will maybe based on the 5-typo source IP, desk IP, and also some APP requirements. It may require high throughput or low latency. And then it will have a decision here. It will choose kernel MP TCP protocol or some native TCP protocol, and also maybe some user space TCP based on the requirement on the APP and also the current networking environment. So this is the RD process. So, okay. Okay, the next one I will introduce the current advancement. So I will introduce how DMM integrate the protocol stacks. Actually, we already integrate some stacks in the latest 18.10. Okay, currently we support the pipeline mode and the partition RTC mode. So this two mode is mostly used in the APP. So some APP need to want the protocol stack running in pipeline mode. It may have a complicated logic in its own process when it's processing the package. And also maybe some of the application want to own all the NICs and run in RTC mode. So DMM want to provide an example on both modes. For the protocol stacks, we integrate LWIP with DPDK mode. This is an example of a pipeline mode. And the RDMA socket stack, which is an example of RTC mode. And also, we do some initial support for VPP host stack. And we provide several demos for multiple stacks using in nginx. And for fork support, we have some initial support of fork. So I noticed that Florian just introduced how it solves the fork problem. So maybe we have some similar solution. And this is an example of how we integrate VP host stack. Actually, the sourcebound DMM-EAL try to wrapper a different I/O base, but the VP host stack has its own I/O base, so we can ignore this module, and the VP host stack will just connect it to the source socket bridge SBR module, and then it will go to a DPDK driver directly. So, but some other protocol stack may use the DMM-EA module, just like the example pipeline mode at WIP. So to integrate the VPP host stack into DMM, we need 3 points. One is an adapter. So this adapter will generate some share lib or VCL. For VPP host stack, it is a VCL lib, share lib, and connect and insert it into DMM module socket API hook. And the second one is a config file. We need 2 files here: a module config.json.json and RD config.json. So these 2 files will tie the DMM framework. What is available protocol stacks like DMM, like a VPP host stack is available, and where to find it. So it will connect the VPP host stacks POSIX API into DMM framework. And DMM framework's POSIX API is hijacked from app POSIX. So we did FD mapping here. By the FD mapping, then DMM framework could work in both in multiple protocols. And currently, we only integrate the VPP host stack front end, the VCL end, and the VPP host stack will still communicate with its backend by SHM or memFD. And this is some example of the config file. The right box is a module config.json. It will specify the DMM VCL share lib, and the stack ID and the stack's name. And the share lib is built from the adapter source file. The source file will define a stack register function and connect all the VCL socket operation functions into the DMM framework. So then the app will connect to DMM, and DMM will use FD mapping, go to VCL. So VCL will be one candidate of the schedulable protocol stack instance. And this is an RDMA stack integration example. The process is almost the same. The difference is RDMA is RTC mode. It just, when it builds the connection between the client and the server, it uses kernel events. And after it build, after the session build, it uses user space event. So we do more when we provide the ePO, connect to the ePO process. ePO event, connect to the ePO event, go into the DMM ePO framework. So the others are almost the same. It will always have the config file and the adapter. So the adapter here will compute, is the same. It will compile into the share lib and specified in the module config.json. Then the whole stack, the RDMA stack will be a candidate into the DMM stack schedule framework. Okay, I will show a DMM demo. That demo is selecting the stacks from multiple based on the requirements. So in this demo, there will be four virtual machines. So the first one is a client. It will connect to a proxy by nginx. And nginx will pass the request, go to, based on the different protocols. One is go to UDP protocols will go to server 1, and TCP maybe go to server 2. And we define the protocol routing policies here. And then the nginx will use the DMM and it will benefit or gain from the multiple protocol stacks based on different APP requirements. And here, some special nginx proxy may convert some special protocol into some upstream real server. So, oh, sorry. Looks like it could not open. Okay, I will introduce this demo. Okay, this is the center of the picture is the reverse proxy of nginx, and we have 3 different CIDRs here, and the client will use one CIDR 1 to connect to the reverse proxy, and the different requests of the client go to different CIDR. Maybe in the upstream, upstream server 1, we have CIDR 2, and upstream server 2, we have CIDR 3. And based on the RD JSON and module JSON, the center nginx reverse proxy will use a different protocol stacks based on the session. So every session may have different protocol stacks. Okay, this demo has been merged into DMM open source repo, and you can check it in the repo. Okay, finally, I will share some our roadmap. So in the future, in the next year, DMM want to full support the VPP host stack. So currently, we only integrate the VCL in the front end. So in the future, we can put the event from the connect the ePO or the other event from the backend. And we also want to redesign the RD module to support auto selection of protocols. Okay, and more flexible memory management to support multiple stacks. And we'll test the performance and provide the index for all the stacks. And we can also do some multiple instance support to enhance the performance. Okay, that's all. Okay, thank you.